Bismillah. Today our lesson, guys, is talking about integration by substitution. Integration by substitution. And simply, you're going to use substitution. You will use substitution method, or always we name it U substitution. When we have the product of two functions, or the quotient of two functions, or when we have a function raised to a power of n, or the square root. So we can say here that we have three cases. The first case, when we have the square root of a function, and this function f of x is not linear, and we would like to find its integral. When you have to find the integral of a function that is not linear and raised to a power of n dx. Number three, also when you have a fraction and it's a quotient between two functions f of x and g of x, you can use U substitution. And so on, guys. We will see where we can use U substitution or substitution method. So the guidelines for U substitution way that we look some composition. If we have a function g of x, like len sine x, it's called the composition, like len, and the inside is sine x. Like what? Also composition, like the square root of x squared minus 1. It's composition, f of g of x, within the integrand for which the substitution. We let the inner function g of x equal u, and then differentiate. And then what? Differentiate both sides. Step 2, if you successful in step 1, then try evaluate resulting integral in terms of u. Then this may or may not be possible. If you are successful in step 2, then replace u by g of x to express your final answer in terms of x. So let's do the first example here, which is evaluate the integral of x to the power of 2 plus 1 all to the power of 50 times 2x dx. I think here we have what, guys? We have composition. The inner function here, x squared plus 1, we can express this function as g of x, or u. Let's solve by using U substitution. So at the right here, I will let u equals what? X squared plus 1. The problem here that we have x squared plus 1 raised to a power of 50, raised to a power of n. So always let what inside the parentheses raised to the power of n, let what inside the parentheses as u. Okay? Step 2 is to differentiate, find the derivative of this sentence, of this equation. Y equals x squared plus 1. Who can differentiate this one? The differentiate of the left-hand side, the differentiation of u is du, okay, over dx equal, then the derivative of x squared is 2x. Drop down the exponent and subtract 1 from the exponent, and the derivative of 1 is 0. The derivative of 1 is 0. And now find the du alone in one side. Du equals 2x dx. So always I will do it like this. Du equals 2x dx. Now find the dx alone in one side. يعني make dx لحالها, to substitute here the dx also. So dx only equal, pay attention please from the beginning, guys, du over 2x. And this way is very, very important, which is substitution way, or U substitution. So I'm gonna use this two inbox sentences. The first one, u equal x squared plus 1, and the second one, du equal dx equal du over dx, and substitute here in the equation or in the sentence. Okay. To evaluate here, I will write the integral of Pay attention, please. X squared plus 1 all will be u to the power of 50 times 2x, okay, times what? 2x dx, right here, 2x. And replace this du by its value, which is what, guys? dx equal du over 2x. You will not hear that we have a common factors up and down in the numerator and denominator, so we can cancel them out. We can cross them out like this. So we have now the integral of u to the power of 50 du. I think now we have all our variables in terms of u, all in u, right? No x's now. The x, we cancel it out and we substituted here by what? Du over 2x. And we replace the x squared plus 1 as u. So all my equation now, all my integrand now in terms of u, right? Yes. And follow the same steps we did in the previous sessions. So now we have to add 1 to the exponent and divide by the new exponent. So it's simple now, guys. Let's add 1 to 50. Gonna give us 51 over the new exponent, 51 plus the c. The final step is to return back everything in its original place. Yani we have to return back the x u, replace the u by x squared plus 1. أشيل اليو تاني and put it as x squared plus 1 all to the power of 51. And here 1 over 51, it can be written like this, plus the c. So this is your final answer. Final answer should be in terms of x. Final answer should be in terms of what, guys? Of x. So again, this way is called the u substitution way. You have to come here at the right and let one part of your question as u. Right. As I said in the previous slide, we have some cases, some common cases to use u substitution. When I have radical, باخد اللي inside the radical or the radicand, let it u. Sometimes when we have, like our question now, 1, we let the inner function raised to a power of n, we take the inner function as u. And when we have fraction or quotient, we can take one of them as u. Any question?
Sir, can you go back to the solving, Mr.?
To the question here, we let x squared plus 1 as u. We assume that u equal x squared plus 1. بعدين we found the derivative. Why the derivative? ليه عملنا derivative? To replace dx also and write it du. Okay, so we have to replace x squared plus 1 as u and replace dx also. So I make a derivative. Derivative du over dx equal to x. And then is over 1. Cross multiplication gives du equals 2x dx. Find the dx alone on one side by dividing by 2x each side. We got here the dx. By substituting by these two boxes here, حطيت بدل x squared plus 1, I substituted u power 50 times 2x times replace the dx, replace it or substituted dx as du over 2x. Cross out 2x with 2x, so you still have u to the power of 50 du. And then add 1 to the exponent and subtract 1 from the exponent. We add 1 to 50 becomes 51 and divide by 51 the new exponent and replace u again by its value, which is x squared plus 1 all to the power of 51 plus c. Any question? This is the first kind of questions we have in our lesson. What's the problem from the beginning, guys? That we have a product of two functions. One of them is to the power of 50. Yani you will not be able to expand x squared plus 1 to the power of 50. But if your question is x squared plus 1 to the power of 2 to the power of 3, maybe to the power of 4, you can expand the first to the parentheses and then times the result by 2x and then do it as we learned before. But here it's hard to expand x squared plus 1 to the power of 50. فطبعا we have to follow the u substitution method. Okay? Any question? Any question? Is it clear now, guys?
Yes, Mr. Clear.
Okay. Good morning. Let's move on to the next question. Also, we have trig function sine x plus 9. So what's the problem here, guys? Can you do it as negative cosine x plus 9 over what? Over 1? No. Since my angle here is not only one term, so I have to use the u substitution method. You can let u equals x plus 9. You can let t equals x plus 9 as you like. Some books use t, some other books use u. I prefer to use what? U. So it's up to you guys. You can use any letter represents the substitution method or the substitution step. أنا أحط u equals what now? Huh? X plus, yes? I'd like to hear you guys.
X plus 9.
X plus 9. And then if we write here the integral of sine and then x plus 9, we're going to replace it by u and dx. Can I write here dx مع u? I have two variables, sine u, and we are finding the integral for x, and we have u, two different what? Variables? No, طبعا. That's why we have to find the derivative of u, du over dx equals the derivative of x, as we learned in the first term, is 1, and the derivative of 9 is 0. Okay, now du equals, with me, cross multiplication, as 1 has a denominator of 1. If we did here a cross multiplication, gonna give us du equals dx. So this is my substitution boxes. This one and this one. We're going to substitute x plus 9 as u and substitute also dx as what, guys? As du. And then do it for you here. Who can find it? Yes, who can find it, guys? We have sine u and its integral. Negative.
The table, negative cosine u.
Negative cosine u. Excellent. Over 1. We will not write it. Plus,
Yes.
Plus the c. Plus the c. And then return the u back to its original value, which is negative, okay, and cosine. And this u, we're going to replace it by its value, اللي هي فوق هنا x plus 9 again, plus c. Okay, Mister, we cannot use u substitution. Yes, we can do it directly. Why? Who can tell why? We can do it directly as negative cosine. We can do it directly. The integral of sine is negative cosine, and then x plus 9, and then plus c. The same answer. But why? What's the reason? Because here
there is nothing outside.
angle linear.
ايوه مستر I said like this. انا قلت كده في وسط الكلام، قلت ان لازم تنفع في حاله ان اللينير بس. Okay, but if it's x squared plus 9, no, we have to use u substitution. So it's optional now, guys, to use direct rule and divide by 1 or u substitution. Both gonna give us the same result. Okay, طبعا ايه الريزن هنا نطلع the same answer? Because x plus 9 is linear. In the previous one, x squared plus 1. We cannot. Okay? Okay, so if you have any question, guys, ask me before
go back to the other
go on to
question?
the next question. Yes?
Can you go back to the other question?
The first one, yes. In the first question, I have a function raised to a power of n, x squared plus 1 raised to a power of 50. For 50, يعني it's hard to expand it. مع كمان multiplying by another function 2x. فهنا 100% you should use substitution way or u substitution method. You have to let what inside the parentheses as u, x squared plus 1 as u, and differentiate to find the dx. يبقى ليه بنعمل differentiation to find the value of dx and substitute عنها كمان. So the du over dx equal the derivative of 2x, the derivative of x squared is 2x, and find the dx by your own way. Substitute u for x squared plus 1 power 50 and substitute d 2x dx. From here you can replace it also. أشيل 2x dx كلها 2x dx all and put du and don't do the next step here. And then find the integral of u power 50 as u power 51 over 51 plus c. بعدين ارجع اليو تاني to its original value, x squared plus 1. Yes, who can do this question? Here's a classwork. Now who can do it? Raise hand, please, guys, to answer this question by the same way, by using u substitution. Tell me first, what's the value of u? Yes, Elias?
Yes, Mr. First of all, we take u as the value of x minus 8.
Excellent. We'll let u equals x minus 8. So
Yes.
my u here is x minus 8. Sometimes the question given for you the value of u. Yeah. Right, then
Yes. And du
equal-
over dx equal 1 only.
Then du equal cross multiplication.
dx.
It has a denominator of 1. When we do cross multiplication, gonna give us dx, right? Okay.
Yes.
So du equals dx and u equals x minus 8. Let us substitute
Yes.
here in the question the integral of
u to the power of 23 and multiplied by du.
dx, change it to du from here.
And now we use our method, which is add 1 and subtract. So u to the power of 24 over 24.
Yeah, and divide by 24 and then plus the c. The u here is رجعها تاني x minus 8 to the power of 24
over 24.
or multiplied by
Plus
1
C.
over 24 plus c. So this is your final what, guys? Final answer. All of you understood this question? We are now 13. I would like you guys all to understand this lesson because it's very, very important to become معك at the to the end. And it's a part of some questions, some upcoming questions. خلي بالكم. Okay. Yes. Next question also is a classwork. Who can do this question? Cosine 5x. Cosine 5x. Yes, I think that we did this kind of questions in the previous week, the last week, guys, by using what? Identities, right? But now, or today, we can use substitution instead of identities because some of you find a little bit hard way to memorize all the identities in the same time. So instead of writing cosine 5x and using the identities, ممكن أحط هنا اليو substitution. We can let you what يا يمان؟ يمان. We can let you as
معك cosine 5x يعني
لا, we let you
5x
as
لحالها.
5x only. Yes, the angle. Okay, we let you as 5x, and you can do it directly as what? Sine 5x over 5 plus what? Plus c.
لأنها linear.
Yes, because 5x is linear. But
Yes,
if
but
we follow
then-
the substitution,
the du over dx يعني
yes, du over dx, or we can find directly du equals 5 dx, because every time I'm going to multiply cross multiplication, it's easy now to find it على طول
Yes.
du is 5 dx. So it's the integral of cosine what? Cosine u, and replace the du by قصدي
5
replace dx as هنا dx equal du over
5.
Yes, this is the dx. So my dx now is changed to du over 5. Yes, 1 over 5 as a constant يطلع برا, and the integral of cosine يا يمان cosine u du.
Sine.
Yeah, it's a sine u plus c, and then substitute again the u by
U
its
for
value.
5x.
Yes, 5x plus what? Plus c.
C.
Yes, so it's the same.
Yes,
Yes,
same answer.
same. But the reason here because it's linear. If it's any other angle, like sine, like cosine, maybe the question is the integral of cosine sine 5x. Okay, cosine tan 5x, cosine ln x, cosine x squared plus 5, cosine radical. Yes, ممكن اغير ال 5x تبقى any other function rather than 5x, not linear يعني. So you have to use u substitution. Okay? Yes, so our lesson today is u substitution or integration by substitution. Integration by substitution. It's a very, very important lesson in calculus. Next question, as I said for you, when we have a fraction or quotient and we would like to cancel it out or make it easier, we replace the quotient, we change the quotient as a algebraic expression with no denominator, or denominator of 1. So the substitution method gonna be help us here. Who can answer? You can think with me here what part we should substitute u by. أي part we can substitute. Yes, Khalid الشاعر. We can let u here. Huh?
u equal 1 over 3x minus 8.
Excellent. We can let u 1 over 3x minus 8.
Yeah.
Yes.
Then the derivative of u, so du over dx,
du over dx is equal to
1 over 3.
1 over 3, and the derivative of negative 8 0. طيب.
Yes.
طلع لي dx.
du is equal to, dx is equal to 3
Do it
du.
one step by one step. So I'm gonna cross multiplication. So it's 1 over 3 dx.
1 over 3 dx. Yes.
طيب dx equals
du over, so 3 du, yes.
3 du. So replace the dx by 3 du. Replace the u by 1/3 minus 8x. So in my integral, the integrand becomes what? 3
3 du.
du over yes.
u to the power of 5.
u to the power of 5. طب this 3 مش احنا قلنا عليها ان هي بتكون constant?
Yes.
Yes, so we let it outside. And the integral now of what? Of 1 over
u to the power of 5.
yes,
du.
du. Okay, Khalid. And then
take u to the power of negative 5.
حلو. يبقى u to the power of negative 5. اللي هي easy now to find its integral.
Yeah,
Yes.
so u to the power of negative 4 over negative 4.
أيوه. u power add 1 gonna be negative 4, and this all over negative 4 plus the c. بعدين رجع اليو تاني to its place. It's 3 over أو negative 3 over 4. 3 over negative 4 is the same as negative 3 over 4. And the u is
1 over 3 x minus 8.
here is the u. The u is 1 over 3 x minus 8. So I'm going to replace the u again by its value, which is 1 over 3x minus 8 to the power of negative 4 plus c. Or
we can put it in the denominator.
حلو. يبقى negative 3 over 4, and it's what now? 1 over 3x minus 8 to the power of 4 plus the c. Okay. So I'll find here your answer. This is your final answer. Negative 3 over 4, 1 over 3x minus 8 to the power of 4 plus c. Any question? Again, guys, we let here, we let what? We let 1 over 3x minus 8, we let this part as u by using our method today, substitution method. Step 2 is to differentiate, find the derivative of this equation with respect to x also. Du over dx equal 1/3. Find the dx to replace this dx here. Dx equals 3 du. And then replace the u by 1 over 3x minus 8 and replace the dx as 3 du. 3 constant, you can move it through the integral symbol, and then 3 the integral of u power negative 5. طبعا 1 over u to the power of 5 can be written as u to the power of negative 5. يعني we can flip and change the exponent sign. Okay, that's it. And then do your steps العادية اللي هي add 1 to the exponent and divide by the new exponent. It's u power negative 4 over negative 4. Replace the u again by its value, which is 1 over a 3x minus 8. ورجعنا تاني تحت في denominator because it's a negative exponent. Okay, thank you, Khalid. Okay, now, before we move guys on and take more exercises, let me ask you if you have any misunderstanding step or part. Any question? So till now we took 4 examples. The first example, evaluate the integral of x squared plus 1 all to the power of 50 times 2x dx. This is the first example in your book. Next example, شوفوا كده if you have any question ولا عندكم أي مشاكل. Third example, number 3. This is the fourth example. Number 3, but here number 2b. Yes, this is number 2b. This is number 2, letter B. And here's question 3 or example 3. Okay, and here example 4. Yes. In the next question, example 5, the integral of 1 over x squared plus 6 squared by x dx. Yes. Can we try, guys, to do it with without using the u substitution method? We can write it as 1 over x squared. Yes, Ahmed Saeed.
X power negative 2.
X power
Yes,
negative
1
2.
over x squared is x power negative 2, so we'll integrate على طول ولا ننسى؟
لا فصصها الأول dx and then the integral of sec squared
secant squared by x
dx.
Yeah. Okay. So x negative power negative 2 is x to the power of negative 1 over negative 1.
Yes, plus.
Right. Plus secant squared. I don't remember the identity بصراحة.
Not identity. The integral directly of sec squared. You think what function its derivative is sec squared? It's tan. Okay. Tan. When you find the derivative of tan gives a sec squared. That's why the integral of sec squared is tan. Tan pi x
tan
over
pi x divided by pi.
By pi plus what? The c. This is with no u substitution, without using the method of our new way today, اللي هو اليو substitution ديت direct way. طبعا الكتاب بيشرح لك بيقول لك ان you can use substitution also method by writing what? You can let here
inside secant squared we can use substitution for u, then the whole function بعدين هي 1 over x squared plus secant squared by x.
You can substitute this all, but it will not be helpful. And I think that we are here to simplify the calculus, okay, not to make it hard. And if you use u substitution in this question, معناها I'm trying to do something hard or complicated. But this way is easier, خلاص, مش شرط. But if we have here Mr. Ahmed power 4.
يبقى u substitution.
لازم استخدم u substitution غصب عني. Because I cannot expand, I can do anything. I have to use this all as u. If we have a power of 4, a power of 2, a power of any thing. Example 6, we have, yeah guys, do you have any question? So move on to example 6, بقول لك the integral, evaluate, find the value of what? The integral of sine squared x cosine x dx. Yes. Yes, who can answer this question, guys? Faris Matar. Yeah, the one I'm gonna ask him, guys, to answer
Yes,
with me.
Mr.
Please open your cam. Open your camera. Faris Matar.
Yes, Mr. Yes.
Yes.
تعطيني
Evaluate.
مسألة الصراحة يا مستر.
Okay, the integral of sine squared x
فين حاجة يا
cosine.
مستر.
Yes.
Yes, Mr.
Miss, I could try.
Yes, Faris. Okay, thank you, Ahmed. You answered. I would like to check the understanding of some other students. Like Faris Matar. Yalla Faris.
Yes, yes.
Yes, mister.
Okay.
دكتور فارس مالك؟ تفضل.
طبعا نحط U equal
Yes.
U equal
As you like. Try. Try let it equal what? X? Or let it equal to
V
sine,
square
cosine.
sine.
Here is the
V
product of.
square sine.
I have an idea. Because the square, is it better to substitute U for cosine X or for sine X? مين اللي عنده مشكلة أكتر؟ Sine.
Sine, yes.
So we let U equal
Sine square X.
sine بس. Sine X. Okay? Okay يا فارس؟
Okay.
أيوه. And then find the
شفنا
derivative.
كنا نعوض بالفانكشن أو الأنجل بس.
No.
يعني U
حسب
equal
الquestion.
الأنجل.
No. Let's try. I will try here. I don't know if it's correct or not. I will try واشوف هتظبط ولا لا. ما هو لازم تكنسل cosine with cosine. Okay?
Okay.
We have two
Mr. Tuck,
problems here. We have
I
two
have a
problems,
question,
guys.
please.
The first problem, and we have product of two functions, sine times cosine. The second problem
Mr.
that we have sine squared. You
I have a question.
لازم تضرب عصفورين بحجر. Yes, sir.
Can we substitute sine squared for 1 minus cosine squared? بعدين then we distribute.
Yes, you can. Excellent. By using what بقى أنت اتكلمت كده using إيه؟ Identity
1
اللي هو إيه؟
minus
السيشن اللي
cosine
فات.
squared.
أيوه اللي هو طبعا الليسن اللي فات. طيب I don't know identities. I forgot that sine squared is 1 minus cosine squared.
حل تاني.
أبدأ أشتغل إيه؟ U substitution. If the question asking you to use U substitution method to evaluate. كده يعني. طيب ال U equal sin X بس thank you يعني. يلا يا مستر فارس ماتر right؟ يلا. U equal sin X. Let's try to find the derivative.
du over dx.
أيوة du over dx equal the derivative of sine.
Cosine.
Is cosine the derivative? Yes, cosine. خلي بالكم. And then replace dx.
No.
أو multiply by dx each side. Multiply each side by dx.
So cosine dx.
Why? لسن في حاجة هنا تقدر تعملها على السريع تبقى أسهل بالنسبة لك اللي هي replacing cosine x dx. Replacing cosine x dx كلها by what? By du.
Yes.
By what? By du. So I can use
By
here du equal cosine x dx, and the u is sine x. So it's the integral of sine squared x.
U squared.
U squared
Yes.
times
times du.
Times du. So على طول بقى.
U power 3 over 3.
Plus c.
Times c.
And replace again the u by its what value. ال u is sin x يبقى عادي ترجع تاني ال u كانت sin x يبقى sin cubed now x over 3 يعني multiplied by third plus c.
Plus c. Okay.
Okay. Thank you فارس. Thank you. طيب زياد عبد الكريم, do you have any question? محمد الزيني.
No, mister.
لا والله شباب all of you, is it easy؟ عمر حوراني. رحمن عماد. يمان. كله تمام؟ طيب. So this is the
لسه متعود عليه.
Yes. طيب. Let's leave these questions right now And let's move on, guys, but we stopped at question or example number 7, 8, 9. We still have from 7, 8, 9 and what? And 10. And let's move on to question number 1 here. Ziad Abdel Karim. Letter A. The integral of 3x squared into 1 plus x cubed to the power of 25 dx equal. هو هنا أعطانا اليو to the power of 25. معناه إنه عمل substitute what؟ إن اليو بكم؟ What to the power of 25 يعني we have 1 plus x cubed to the power of 25 يبقى he replaced the u by زياد by what 1 plus what x cubed and the du معناها to find the derivative يبقى du equal the derivative of 1 is 0 plus the derivative of x cubed طبعا which is 3x squared dx خلي بالك ما تنساش. So we can write du as 3x squared dx. This is one kind. Letter B and C homework in quick check exercise 4.3. Number 2, all A and B. And from question 1, A and B, 2 A and B, 3 A and B, 4 A and B. Okay. So again, I will write for you here the homework. So your homework, guys, please pay attention. Here quick check exercise 4. الأول quick check exercise بيكون فوق الset exercise. Number 1 B and C. Number 2 A and B. Number 3 which is all A and B, and 4 A and B. Thank you and see you inshallah tomorrow. Goodbye, guys.
سر يمكن علينا حصة تاني.
No, we don't have. Today only we have 2 periods. 1 period. بكرة الاثنين والأربعاء something like this. الاثنين والثلاث. Okay.
Thank you.
Welcome. Salam alaikum.